Hi, and welcome to the second class here at Numa TV about iOS development. Today, we're going to cover two things. First of all, we're going to start off with the basics of of the Swift syntax. So this is going to be the first half of this session. And in the second half, we're going to dive right into auto layout and size classes using Xcode. So without losing any time, let's switch to Xcode or Playgrounds. So if you want to follow along, I'd suggest that you bring up Xcode and create a new playground. So all you need to do is open up the Xcode app and then create a new playground in the left bar. And we're going to start off with the absolute basics. So it's not bad if you have some experience with programming itself in another language. So now we will start with variables, move to constants, and control flow later on, and everything, of course, Swift specific. So let's learn the essentials of Swift. And what I have here is an empty playground. And as you can see at the top, it states that the playground is a noun, and this is a place where people can play. And this is exactly what we're going to do now. And there is an import statement here saying UI kid. That doesn't matter right now. We will simply ignore that and think about it as we will put it to the future and think about that later. And the next line that it states here is a var, a string, and then it says here hello playground. And what we want to do is simply get rid of that. At the moment, we are going to write our own variables. And we will start with the first variable using the var keyword, which says the compiler that this is going to be a variable. And we're going to name this variable, in our case, my variable for now. And this is all there is to it, to creating a variable. And a variable, of course, is mutable, so you can change stuff within it. And at the moment, our variable is pretty empty, so we can assign something to it. Let's say we assign 42. And since it's a variable, we can change its value. And to do that, we will simply use its name, which is my variable. And as you have seen, as soon as I write my or just an m, if you do it at your computer, you should see a little window that tries to autocomplete what we just write. I think it's not covered in the stream, but just try to type in this my, and you will see that my variable is one of the results that you can use. And if you just hit enter, then my variable is auto-completed for you. So as soon as we have the name of our variable, we can assign another value to it, let's say 50. And this is all there is to changing such a variable. But what about a situation where you know that you don't want to change a value again? We're using constants for that. And to create a constant, we use the let keyword. So we write let and my constant. And we can also assign 42 to that constant. And in comparison to a variable, we can't change anything. I can write my constant here and try to assign 20, for example. But as soon as I did that, I get an error which says cannot assign to value. My constant is a let constant. And this simply doesn't make sense at all because we do not allow this constant to be changed. And just to recap this, a constant is a value that stays the same after it's declared the first time, and while a variable is a value that can change. A constant is referred to as immutable, meaning that it can't be changed, and a variable is mutable. So if you know that a value won't need to be changed in your code, then declare it as a constant. And use let to make that constant and var to make a variable. So every constant and variable in Swift has a so-called type, but you don't always have to write the type explicitly. So in our cases, we have assigned numbers to it, and these numbers are integers. So the compiler infers, in our case, that my variable is an integer because its initial value is an integer. And this is called type inference. And once a constant or a variable has a type, that type cannot be changed. And if the initial value doesn't provide enough information, or if there is no initial value, we can specify the type. And let's just see how we can do that. So we will create another constant, and let's call that implicit integer. And then we assign 70. And my goodness, here. And once we have assigned that, our compiler knows that this is going to be an integer. We could do the same thing with an implicit double by simply assigning a double value here. And if we are not sure if our value is going to be an integer or a double in the future, what we can do is, for example, create a variable, which is an explicit double. And by writing a colon and stating the type afterwards, in our case double, we can assign 70 just as an integer, but our type of this variable is going to be a double, and we can change that in the future. But sometimes we really need to convert types. And how can we do that? Let's create three constants here. First of all, let's create a label. And let's say this is going to be a string, and we say the width is. So this is simply the content of a label. And now let's create another constant and give this an integer value, and stating that this is 94. And with that, we know this is an integer, and this is the width of our label. So now let's continue and create a third constant, the width label, where we want to connect the label string with the width integer. And what we can do here in Swift is simple. We can simply use label, write a plus sign, and add the width. But this again gives us a compiler error, because this does not work. We cannot add a integer to a string. So what we need to do is we need to convert that type. And to convert that, we can write string and some parentheses. And as you can see here in the sidebar on the right, that now we have connected both strings, and it now says the width is 94. So this is one way to connect strings. I'd like to show you another way, which is called string interpolation. And what we can do here is, let's create another example. First of all, let's create a constant called apples. Let's say we have 3 apples. Let's create another one, oranges. Say we have 5. And now let's create an apple summary, saying that I have some apples. And instead of these 3 dots, what I like to do is put in the number of apples. And to do that, what we need to do is writing a backslash and some parentheses, and then we can simply insert our apples constant. And again, as you can see here in the sidebar, it says now I have 3 apples. So again, with the value in parentheses and writing a backslash before the parentheses, this is known as string interpolation. And we can do even more with that. Let's call this fruit summary, the next constant. So let's say fruit summary. And let's say now I have so and so many pieces of fruit. And again, we use backslash and parentheses here. And this time we will insert the apples and add the oranges. And now instead of let me just copy that here. And now instead of having only 3 apples, now we have 8 pieces of fruit. So using string interpolation, we can even do basic mathematical operations here. So this is also very great, a great feature of Swift. So let's move even a step further in the Swift basic syntax features. And there is something that even if you have used another programming language before, you might be unfamiliar with. And this is called optionals. And we use optionals in Swift quite often. So why do we use optionals? Well, first of all, let's see how an optional looks. So what we do is, again, create another constant, and let's call this optional int. And now we will assign the type directly using a colon. And to mark this as an optional, we have to write a question mark. And then I will assign simply 9 or something. You can assign whatever you want. And we use optionals to work with values that might be missing. So an optional value either contains a value or it contains nil. And nil means no value, to indicate that a value is missing. So writing a question mark after the type of a value to mark the value as optional. And as I said, optionals are very common in Swift, and they are very useful for many situations where a value may or may not be present. They're especially useful for attempted type conversions. So let's have a look at that. We already saw how we can actually convert types as we did that here with the string. So let's create another example. Let's create a variable, call it myString, and assign a string with 7. And what I didn't mention before, so a string is always written within quotation marks. So just remember that if you write a string, put it into quotation marks, and that's quite common to almost every programming language. So you do it that way. And now let's convert this string into an integer. So let's say possible integer, and we use the same syntax as before. So we use int and parentheses, and what we put in is myString. So as you can see here in the sidebar, here we have a string of this integer, which is 7, and here we have just the number, the integer itself, which is also 7. And then what we can also do is print our possible int, and the print statement is nothing else but printing something to the sidebar or in the console within Xcode. And as you can see, the syntax is the same as with int here or Swift here. We simply write print, some parentheses, and then we can put in the possible int variable. And as you can see here now, in the output here on the right side, it says that it's optional, an optional with the integer 7. And let's try something else, because we saw that in this code the value of possible int is 7 because myString contains the value of an integer. But if you would change the value of myString to something else that can't be converted, let's see what happens then. So let's change it. So myString is a variable, so we can use it again. And let's add maybe banana. And now let's try the same thing. Again, we use possible int, and we try to convert myString again. And then we print the possible int again. And let's see what happens now. As you can see, possible int now became nil. We have no value. And when we print it again, we see nil here. And in comparison to Objective-C, for example, the programming language used to create Apple iOS applications and macOS applications previous to Swift. In that case, there were no optionals. And if you attempted to do something like convert a string that contains banana to an integer, your app would simply have crashed. So this is quite interesting using optionals, and this is also an interesting concept that we will cover along the way quite often. So let's now talk about something else that is that's quite important for developing applications. And let me bring up an image for that, because we are going to talk about arrays. And arrays are widely used in different programming languages. And let me just bring up this image of some drawers. An array is actually a data type that keeps track of an ordered collection of items. We will see in a second how we create arrays in code. But for now, let's have a look at this bunch of drawers right here. So as you can see, each drawer has its own index, which starts at 0, just like an array that starts counting at 0. So we can put something in this drawer, and it's called 0. And we can move all the way down. We have 10 of these drawers, and in every drawer we can put one string, and we can access those drawers by simply stating their index number, like 0 or 5 or 6, 7, 8, or 9. So the most important thing at the moment is, and for the future, because there you can make a lot of mistakes there, is to keep in mind that an array always starts counting at 0. So let's move back to the playground and see how we can actually work with arrays in code. So first of all, let's create a variable. Let's call that, let me give me some space here. And let's call it rating list. And to actually create an array, all we need to do is using brackets. So here we have some brackets, and we can now add some ratings like poor, fine, say there's also good, and let's also have excellent. All right, so this is now an array of strings. Just as we've just seen with the 10 drawers, now we have actually 4 items in it, so we would have 4 drawers. And poor would be the index 0, fine 1, good 2, and excellent 3. Now, if we were to change fine, to do that, we would need to write the name of our array, use the brackets, put in its index, which is 1, and then we could change it to OK. And as you can see now, if we compare the first array that we have here, rating list, I'm just going to write rating list here again, and then we will get the same array just with another value for our index 1. And as you can see here, at index 1, we have fine, and here at index 1, we have OK, because we have changed it using those brackets. So this is very important. And sometimes you also want to create an empty array and fill in information later. So to do that, we could create a constant, or let's create a variable here. Let's call it empty array. And to create such an empty array, we do not assign, again, a number of things. But what we want to do is we can write brackets again. And within those brackets, we specify what type our variables should have, or our elements should have. And in this case, let's create an array of strings. And to create it, the syntax requires to write some parentheses after it. So this is the syntax for creating an empty array. And we can also write a another very important point in developing applications, which is writing comments. Comments are a great way to organize your code, because you can write above your code what you're actually doing. And there are 2 types of comments. The first comment is an inline comment, which gives you the opportunity to simply write 2 forward slashes to state now a comment follows. Or if you have multiple lines of comments, we simply write a forward slash asterisk, and then the same thing reversed for a multi-line comment. So with that, using comments or using comments is very important, so that if you write a bunch of code, then comments enable you to write down what your code actually means. And then in 1 year, if you look at your code again, you can simply read your comments and you exactly know what you actually wrote a year back. So this is quite important, and we're going to use comments in our sessions as well. So keep that in mind. And we will now continue with another basic language feature of Swift for control flow. So we are now going to talk about if statements. We're going to talk about loops. And let's start with an if statement. And if you've never worked with an if statement before, let's just say that an if statement checks whether a certain condition is true. And if it is, the if statement evaluates the code inside the statement. So let's create an example. Again, let's make some space here. And let's see what happens when we create a number constant. We assign 23. And now let's create such an if statement. And in Swift, we simply write if, this keyword. Then we will define a condition, and we will check if this number is smaller or less than 10. And if that is the case, we want to do something. So we want to print something. In our case, let's just print the number is small. And with that, we check if our number is less than 10, then we print this string. Again, we use this print statement here, the keyword print, parentheses, and within it is this string that we put into quotation marks. So this is one possibility. Let's change our string for a second, because as you can see, there is no output. There's no output because our condition isn't true. So let's change our number to 9. And what happens is that our print statement is called because now the condition is true, and we come to this statement, and the statement is evaluated by our compiler. So what else can we do with if statements? We could, for example, specify another if here. So we could write else if and define another condition. Let's say the number is greater than 100. What we want to do now is, again, writing a print statement, and within it a string. So the number is pretty big in that example. And we can also do something else using an else statement by itself and covering all other cases. And now we will simply print the number is between 10 and 100. So let's see what happens. At the moment, we have number 9. And this means this is a small number. Let's now add something like 76. And now we should get the number is between 10 and 100. And let's now create a number, or change the number to 110. And now, as you can see, it is evaluated as the number is pretty big. So this is what we can do with if statements. And you will be using if statements quite frequently. So this is one of the most important things that you can learn about programming in any language, actually. So let's continue with something called loops. And what we are going to do now is that we are going to nest different kind of statements to create interesting behavior. And in our example now, we will use an if statement with an else clause nested inside a so-called for-in statement. And a for-in statement iterates through, for example, an array, and does that one element at a time, one by one. So let's see how this works. Let's create something, maybe sports scores. Let's create individual scores. And let's create an array for that. Let's say we have 75, 43, 103, 87, and 12. And let's also create a team score and assign 0. And now what we want to do is we want to check every score in this array of integers. And what we want to do is we want to check if our score is greater than 50, we want to increase the team score by 3. And in any other case, we want to increase the team score by 1. So to do that, we will use a for-in loop. And such a for-in loop works that way. We define, we write the keyword for, we define a variable that we can use later. And in our case, we want to check the score in individual scores. And I should maybe correct that, scores and scores. And we now check for each score in our individual scores array. We want to do something, and we write that within curly braces, just as we did with the if statement. We also use curly braces here. And now we will use an if statement again to check if the score is greater than 50. And if that is the case, we want to increase the team score by 3. And else, we want to increase the team score by 1. And as you have seen right now, to add something to a variable, like an integer, we can simply write plus equal. And there's another possibility. What we could do here, instead of writing plus equal, we could also write team score equals team score plus 3. That would be the same thing as writing plus equals 3. So this is just very short here. You could also use that with minus, times, and also when you divide something, but we will keep plus here, of course. And as you can see here in our sidebar, this statement here is called 3 times, because 3 times our individual score is greater than 50 in this case, and in this case. And the other cases where we just add 1 are just called 2 times, because just 2 times here with 43 and with 12, our score is below 50. So this is a great way to create interesting behavior in your program, nesting together different kinds of statements. And we will simply print now our team score to see what it actually is, and we have a team score of 11. So we just calculate that using a for in loop together with if statements. So we can also do something great with if statements that is called optional binding, using an if statement to check whether an optional contains a value. So if you remember, we talked about optionals earlier, and optionals can either have a value or be nil. And we will check that and see what happens. Let's create an optional name. It's going to be a string, and we define it as optional by writing a question mark. We then assign a name, let's say John Appleseed. And let's now create another variable, call it greeting, and just say hello. And then we want to check if our optional name contains a value. And to do that, we create an if let statement, have a variable here, which we can assign our optional name to. And then we write some curly braces. And then we change our greeting to hello. And then we use string interpolation, backslash, parentheses, name. And as you can see now, we have hello, John Appleseed. And there isn't something about optional here stated in our sidebar, because what happens if this works? So if we can assign optional name to this constant name, then what happens is that it gets unwrapped. So an optional can be unwrapped if there is a value in it. So we can just try a little experiment. We can change our optional name to nil. And as you can see now, because this is nil, we do not get to this line of code here, because now this assignment of optional name to name does not work, and we cannot unwrap our optional value. So let's put something in here again, just John Appleseed again, so that this works quite nicely again. So this is what we do with if we're working with optional binding. So just to recap again, if the optional value is nil, the conditional is false, and the code in the braces is skipped. Otherwise, the optional value is unwrapped and assigned to the constant after let, which makes the unwrapped value available inside our block of code. So this is maybe a bit complicated at the moment using those optional, because it's maybe an unfamiliar paradigm, but we're going to come to that quite frequently in the future. So just keep in mind that there are optionals and we can unwrap them, and we can use an if-let statement to get the information out of it, and also keep in mind that an optional can either have a value or be nil. So just so much for now regarding optionals. So let's now take a closer look at loops, especially the for loop. And we'll create a new example for that. So let's create first for loop and assign 0. And let's say we want to do something 4 times. So what we do is we can create a for loop. We can use the I as a counter variable and use it, or just as a handle that we can use later on. And again, we use the in keyword and then write 0 ... less than 4. And now we can use first for loop and simply assign our, or simply use our variable here to count or to add something to our variable. And as you can see here, our variable or our for loop was called 4 times. And this is called the half open range operator, just this one. And this doesn't include the upper number. So this range goes from 0 to 3 for a total of 4 loop iterations. And we can also use the closed range operator, which would look like this with 3 dots. So let's just create another example for that. So a second for loop. And let's also assign 0 to that. You can also maybe print our result here, just the first for loop. And as you can see here, we have reached the number 6. So we were at 0 here, and every time we went through our loop, we have assigned, or we have added the value here. And for the first iteration, we were at 0, then 1, then 2, and then 3. But we didn't reach 4. And now let's do something else. Let's create another for loop using an underscore here. And again, in 0 to 4. So we have now the closed range operator. And this helps us to make a range that includes both values, 0 and 4. And we can then, again, write some curly braces here, use second for loop, and let's say plus equals 1. So every time add 1, and then let's print that. Second for loop. As you can see here, now our loop was called 5 times, or we iterated 5 times through our loop from 0 to 4. So this range goes from 0 to 4 for a total of 5 loop iterations, and the underscore here represents a wildcard which you can use when you don't need to know which iteration of the loop is currently executed. So here, using the I, we know every time which iteration we actually are in. So this sometimes is quite helpful. And now for the last bit of information that you will get today about the Swift programming language, let's come to functions and methods. And a function is nothing else but a reusable named piece of code that can be referred to from many places in a program. And if you're familiar with other programming languages, this is also quite common for programming applications. And to create a function in Swift, we simply write the keyword func, followed by the name of this function. And then there is something called a parameter list. And a parameter list, let's create some parameters here, is nothing else but a list of different variables that you can use to work with within your function. So let's create a name here, which is a string, and a day, again, a string. And we can later use those two parameters, which are of the type string, in our within our parentheses, within our curly braces here. So a function is, or the function body is always located within those parentheses. And the function also has a return type that it gets back to the position where it was called. And in Swift, we do that with a minus sign and a greater than sign, which looks like an arrow. And then we can define the type of this return value, which in our case is going to be a string. And we get an error here because it says there is a missing return in a function expected to return a string. So we can now simply return something. So we return hello, and then we use string interpolation. Again, we use the parameter name. Today is kind of a day. So again, string interpolation. And it's going to be a lot more clear what this function really does in a second. I'm going to call it by writing nothing else but greet. And now it suggests that I put in a name and a day. So I'm putting in Anna, and today is maybe Tuesday, or actually Thursday. And as you can see now, we get hello Anna, today is Tuesday right here. And as you can see, we get the same output 2 times, because what we write here, greet, with our with the parentheses and then putting in Anna here, this value is let's say is transferred into our function parameter list here, and this day again is also transferred into our parameter list, and we can then use those parameters within our function. And because we return a string, we can also see the same output that we see here, right here at the position where we actually called it. So let's try that again. And this is why we're actually using functions, because we don't want to write the same piece of code time and again, and we can simply use other parameters here. Let's use Bob maybe. Let's say it's Friday. And let's do it again. Let's say greet, maybe Charlie this time. Charlie, and he says, what a nice day. So as you can see, we now have called our function 3 times, and every time we get kind of the same result, because we want to return hello, the name, today is Friday, Tuesday, or a nice day. So let's just recap that for a second. We use functions to declare, we use the func keyword to declare a function. A function declaration can include 0 or more parameters, just as we did here, written as name, and then with a colon and the type just in addition to it. And we can, and there are also additional pieces of information that must be passed into the function when it is called, when we have defined those parameters. And a function can have a return type, which is written after this arrow kind of thing, which indicates what the function returns as its result. And a function's implementation goes inside those curly braces. And functions that are defined within a specific type, they are called methods. And methods are explicitly tied to the type they're defined in and can only be called on that type. So let's just, for a quick example, we have a function here. Let's now talk about methods, and we will do a quick example here with an example string maybe. And we use hello here, and then we use the if statement and if the example string, and now the string is a specific type, and we can use different functions with this string, and for example has suffix, and we can check if our string ends with LO. And let's do some curly braces here, and let's print ends in LO. And this is somewhere defined as a function, but because we call it on a specific type, this is actually called a method, just to make that clear. And let's maybe do another example on how to actually call functions, because we are using the dot syntax here. We're simply writing a dot on that type. Let's use an array again. We already know how that works. So we're using some brackets here, put in some strings, apple, banana, let's maybe say a dragon fruit. And right after that, we maybe think, we want to add another item to our array. So what we can do is use array, our variable, write a dot, and now we can call a method of an array type, and we can do insert. And we now want to replace our dragon fruit with a cherry, for example. So let's write that down here. And we want to replace dragon fruit. So this is index 0, banana is index 1, and dragon fruit is index 2. So let's write 2 in here. And as you can see, we again have some parameters here. The first parameter is what we want to insert, and the second parameter is the index where we want to insert it. And let's just see if this worked. And with that, we have another output here, which now has cherry here at the index 2 and moved on, and the dragon fruit just moved one index up. So these were quite many information. This was a lot of information about the Swift syntax now packed into 40 minutes. This is kind of thought as a kind of a reference where you can go back and have a look at different things like constants, variables, how to work with comments, how to work with if statements, just with very simple examples. And we're going to move on to other Swift syntax features in the next session. But for now, what we want to do is closing down this playground and move on to Xcode for some simple examples on working with auto layout and working with size classes. Later in the one-to-one sessions in the private classrooms, we're going to talk about these Swift features in detail, and you can also ask questions about it. But to give you another piece of valuable information about size classes and about auto layout, we will now move to Xcode. So I'm going to close my playground right here, and we'll bring up Xcode again. So let me just give you a first introduction to those adaptive user interface features before we dive into the practical elements. So here we are. Let's talk about adaptive user interfaces again. And adaptive user interfaces means designing for different sizes and orientations. And Xcode provides us with an adaptive user interface technology that is very efficient and very efficient way of designing our user interfaces to adapt to different situations. So let's have a look at different screen sizes, resolutions, and orientations. Consider how many iOS apps run on a variety of devices, such as the iPad Pro, the iPad Air, the iPad Mini, and different kinds of iPhones. And rather than create multiple versions of our app's user interface for each specific device, screen size, resolution, or orientation, we can build our interfaces once in a very flexible way that adapts to different circumstances. So in this example image, you see different kinds of user interface states like an iPhone, iPads, and all those different screen sizes, which means that we really need to think adaptable, and we really need to think about relative positioning and sizing. So for example, think about when you want a user interface component to appear in the middle of your screen. So if you position an element, say 245 pixels from the top and 197 pixels from the left, what would that mean when the device is oriented horizontally? And what about when the app is on a larger or a smaller screen? So thinking too specifically about pixels or points may lead to unintended positioning of user elements on different devices and orientations. And we already saw that last week in our one-to-one sessions in the private classrooms. So what we need to do is, instead of thinking in points and pixels, we need to think relatively and abstractly. And you have probably noticed that Interface Builder provides us with a square canvas, but none of today's iOS devices have a square screen. So this square canvas is really an abstract screen size, and most of our user interface designs will occur here, and iOS Auto Layout will adapt it to different sizes, screen sizes, such as the iPhone in Portrait or the Compact with regular height size class, as it is stated here. And there are many other ways that we can explore that. And keep in mind that you can always use the Interface Builder Assistant Editor to preview your interface. We're going to see that in a second. And we are going to use auto layout and constraints right now to create some more advanced user interfaces. And the secret to all of this constraint stuff is that we use constraints to define how things should be positioned relatively. For example, positioning a label relative to the vertical and horizontal center of the screen. And auto layout takes care of the rest for us, ensuring that our user interface will appear as we intended within different size classes or screens and orientations. And constraints can be very powerful and sometimes complex, but we will practice on learning how to create minimal constraints simply and efficiently. And the trick is to recognize that just because something looks a certain way on our canvas and interface builder, that does not necessarily mean that this will also look like that on the device. And the constraints control how things look. You know that what you see on the canvas and what you will see in the running app are the same when the constraints are blue. So Xcode highlights the things, and we are going to just explore that now in a second. So I will bring up Xcode again, and you can do the same. And I will create a single view application. And let me just change the live stream for a second. And let me share just the entire screen with you. So what I have here is my Xcode window, and I'm going to create a new single view application. I will call that single view application, let's say constraints. And I will create that on the desktop. And what I want to do now is opening up my main storyboard. And we will now see how we can use different views and how we can align these views using auto layout constraints in a more complex way than we did last week. So I will write into my lower right object library UI view, and I will simply drag one of those views to my storyboard and position it something like that. So, and I will then use the attributes inspector in the top right corner to change my background color, let's say something like this. And then I will copy my view and position it somewhere here. And let's add another view just to the bottom of this. I simply copied it again. And notice that I need to be careful not to drag my view into one of those other views, because if I did that, they would be a subview of that particular view. And maybe let's just remove that one and continue with those two. That's cool enough for now. And I will increase that so that they kind of fill the screen, and I give the other one another color. So what I want to do now is have a look at how this looks on different devices. And what I can do is bring up the assistant editor here at the top right corner and change that from automatic, this is the so-called jump bar, and I change that to preview main storyboard. And by using that preview, I can actually see how this looks now on an iPhone 4-inch. But I can also add another screen size like the iPhone 3.5-inch. And you see that it looks nothing like we would imagine. Actually, we want this to look something like that here with our in our interface builder screen. So without actually running our application, I can see my preview here, and I'm going to add some constraints now. So I press Control on my keyboard to add those auto layout constraints. And I have many different ways of adding constraints, and we're going to use one way now that will let you understand how this works, I think, a little better. So every time you want to set a constraint manually, you press Control on your keyboard and click Drag to, for example, the top left corner. And I want to add a leading space to contain a margin and a vertical spacing to the top layout guide, which means that we have added a constraint to the left and to the top. And to actually select two constraints at once, you have to press Shift. So I'm going to do that again. I press Control on the keyboard and drag my line here to the lower left corner, or let me just say to the bottom. And then I get some suggestions based on the direction I pointed my line to. And I will now add vertical spacing to bottom layout guide. And now we have, as you can see on the right side, something that looks a bit more close to what we actually want to see. Now, what we also want is that our two views are identical in width. So what we can do is we can press Control on the keyboard and connect both views together and state that we want to have equal widths. So now we see nothing actually, because we need to define some more constraints, and you see different red lines, you see some blue lines, and what we want to see actually is a lot of blue lines. Actually, we only want to see blue lines. So let's continue by adding another constraint from this view to this view, stating that we want to fix their vertical spacing, just not their vertical spacing. I have to reverse that, pressing Control Z. So I want to add a horizontal spacing that you can see here right now. So this is the spacing between this view and the yellow view. And now let's add another constraint by click drag to the top right corner, saying that I want also vertical spacing to the top layout guide. I press Shift on my keyboard now to select trailing space to container margin. And the trailing space to container margin is the space from the right corner of my view to the so-called container margin. So I press Enter, and I have added my view. I've added those constraints to my view, and now this again looks more like it here on our right preview side in the assistant editor. All that's missing now is that our view does not fill the rest of the screen in vertical direction. So what we need to do is add another constraint, which we do by pressing Control on the keyboard and dragging to the bottom of the screen. And now saying that we want vertical spacing to the bottom layout guide to be this. And as you can see now, we have created the correct layout for our views. And we still see some orange lines here. So let's have a look what's wrong here by simply clicking on this yellow indicator. And I will now click on this arrow, on this exclamation mark here, because now, as you can see, there is an expected width of 264 and an actual width of 266. So we have to change that. We can simply do that by clicking on the exclamation mark, update frames, and fix misplacement. And we can do the same thing right here. So now we have added our constraints. And now let's see what actually happens if we rotate our device, for example. And as you can see, it automatically adapts to the different situations on different screen sizes. And let's do the same thing maybe for an iPhone 5.5 inch. And as you can see here, there happens the same thing. So using constraints is really, really powerful. And even if it seems a little intimidating at the moment, once we practice this a few times, it will become second nature to you. And the benefit is that we can design our interfaces once, and all the layout will adapt it to as many devices as we wish. So let's wrap it up for now and move to the private classroom. And thanks for watching if you're not part of this NUMA class yet, and we'll see you next week.